Hello everyone, my name is Karan Mashru. Welcome to this video. In this video, we are going to look at the solution of the problem, that is maximum of all subarrays of size k. First of all, let us start by understanding the question. What does question say? Given an array of size n and an integer k, find the maximum for each and every continuous subarray of size k. So basically we are given an array ARR which contains n elements, and for every continuous subarray of size k, we need to tell what is the maximum element in that subarray of size k. Okay, so for example, if we look here, suppose n is equals to 9, there are 9 elements in our array and k equals to 3. So we want to tell the maximum element of the first 3 size subarray, then second 3 size subarray, then third 3 size subarray, then fourth 3 size subarray, and so on. So what is the first 3 size subarray? 1, 2 and 3. The maximum is 3. So output is 3. The next 3 size subarray is 2, 3, 1. The maximum is 3. So output is 3. The next 3 size subarray is 3, 1, 4. Maximum is 4. So output is 4. The next 3 size subarray is 1, 4, 5. Maximum is 5. So output is 5. Then 4, 5, 2. Maximum is 5. Output is 5. Then 5, 2, 3. Maximum is 5. Output is 5. Then last 3 size subarray is 2, 3, 6. Maximum is 6. Output is 6. You can have a look at the explanation here. Similarly, n equals to 10, k equals to 4. You can look at the explanation in the example here. You don't need to read input or print anything. Complete the function max of subarrays, which takes the array n, that is the size of the array, k, that's the size of subarrays which we need to consider as input parameters, and returns a list of integers denoting the maximum of every continuous subarray of size k. So we need to return a list which basically contains the maximum of all k size subarrays. Okay, the expected type complexity is big O of n and expected auxiliary space is big O of k, and the constraints are given here. So if we think about solving this problem, then first of all understand that what is the brute force approach. The brute force approach is to basically traverse all the subarrays of size k separately, and for every subarray which we traverse of size k, we will keep the mark of the highest element or the largest element, and then we will add it to our answer list. So basically we will traverse the first subarray of size 4, then we will again traverse the second subarray of size 4, then we will traverse the third subarray of size 4, and every time we will maintain a maximum element. So what will be the time complexity? See, there will be n minus k plus 1 subarrays of size k, and each subarray will contain k elements. So the total time complexity would be big O of n minus k plus 1 into k. Now this will give us time limit exceeded. We want to solve it in big O of n only. So we need to think of something more efficient. So now what can be an efficient way that we need to think of? Okay. So what can be the efficient way? See, what I will do is I will take a queue in which, or better to say, I will take a deque. Now what is a deque? Deque is a queue in which insertion and deletion can take place from both ends. Okay, what is queue? Queue is it is first in first out. Okay. So basically there is insertion from the end and removal from the front, but in deque you can insert the element from the front as well as remove the element from the front side, and delete the element from the back side as well as add the element at the back side. Okay, so let's say we have 1, 2, 0 and 3, and let's say I want to insert a new element 4. I can insert it on the front also, I can delete element from front also, I can insert a new element at the end also, and I can also remove the n element from the end. Okay, so that can be done from both sides. Okay, so I will take a deque. Okay, why we will take deque, that will be clear in a while. Now in that deque, at any given moment of time, so I will be considering a subarray of size k, right? So I will have at max k elements. So in that deque I will have at max k elements which are a part of that subarray which I am considering. Okay, I will not have other elements. First thing. Second thing, when I will consider a subarray of ith element in which the last index is I. Okay, so let's say I am considering a subarray of size k in which the last index is I. Okay, so before this I would consider the subarray of size k in which the last index was I minus 1, right? Now I am considering a subarray of size k in which the last index is I, for example. So I will insert the ith element in the deque, right? Because it was not on the deque. Why? Because it was not a part of this subarray which was ending at I minus 1. But now I need to add it because it will become a part of the subarray of size k. Now before adding it, what I will do before adding it, I will remove all the elements from the back of the cube which are smaller than I. I will remove all the elements from the back of the deque, okay, which are in the deque. Let's say they are at index j, which are less than equal to array of I. Now, why will I do that? And I will also remove the elements which are not a part of the current subarray. Now, why will I do that? Because let's say this is my array, okay. Let's say I have 3 year, I have 4 year, and I have 5 year, okay. Now I am considering a subarray of size k which is ending at 5, okay. So tell me, if I insert 5 in the deque, before that understand, I want the maximum element of this subarray of size k. Now since 4 and 3 are less than 5, they cannot be the maximum element of this subarray because 5 is greater than that which I am at index I. Also, for the further subarrays of size k, please hear this clearly, for the current subarray, 3 and 4 cannot be the maximum element, okay. In deque, what I will keep the at max k elements which are a part of the current subarray, okay, and I will remove useless elements. So before entering 5 in the deque, I will remove 3 and 4 even if they are a part of current subarray. Why? Because they cannot be maximum element for this subarray because 5 is greater than 3 and 4. And they also cannot be maximum element for any further subarrays of size k which I consider. Why? Because the further subarrays which I will consider will be of this type. Now in this, if 3 or 4 is a part of that subarray, 5 will definitely be a part of that subarray. If 3 or 4 are a part of any further subarrays, 5 will definitely be a part of that subarray. So 3 and 4 will not get a chance to become the maximum element. It may be possible that 3 and 4 are not a part of the subarray, but 5 is a part of subarray, okay. So for all the subarrays which are ending at 5 or after 5 of size k, 3 and 4 will never be the maximum element because either they will not be present in it, and if 3 and 4 will be present, 5 will definitely be present, and so they will not get a chance to be the maximum element. Are you getting my point? So before inserting a new element in the deque, from the back side, I will remove all the elements which are smaller than that element, okay. So always what I will have in deque at max k elements which are in decreasing order, okay. You will also see the decreasing order right now, okay. And I will only keep the elements which are a part of the current subarray, right? So what I will do, from the front part, whichever elements are not the part of the current subarray, I will remove them after every iteration. So I will get in deque, I will get a decreasing array or decreasing format of elements, and this will be the part of the current subarray which I am considering, and hence the first element of this deque will be my answer for the current subarray. Suppose my elements in the deque are 10, 8, 2, 1. So these are a part of the current subarray which I am considering. So 10 will be the maximum element because this is in decreasing form. So the first element will be my answer for the current subarray. Now I hope there might be a little confusion, but as soon as we will see a dry run on this example, everything will become clear, okay. So let me just clear this much part out, and now let us dry run. So what I will do, one by one I will start adding elements in my deque, okay. So let me call deque as q. So I will add 8 to it, right? Then I will add 5 to it, but 5 I will add, 8 is greater than 5, so I will keep as it is, okay. After index number 4, I will start adding answers to my elements, because what does 8 and 5 mean? I am considering this subarray. I want to consider the subarrays whose size is equal to 4, okay. So after I reach this index, I will start adding the maximum element to my answer. Now when I insert 10, what I told, if there are smaller elements than 10, I will remove them. So I will remove 5 because I will remove from back side, right? Now because this is in decreasing order. Now after removing 5, I observe that 8 is also smaller than 10. So I will remove this also, and I will add 10 to my deque, okay. Then comes 7. Now understand this from this example. When I added 10, I removed 5 and 8. Why? Because for any subarray of size k which contains 10, it may contain 8 and 5, it may not contain 8 and 5. For example, in this subarray 8 and 5 are a part of this subarray which contains 10 also, but for this subarray they are not a part. For this subarray 8, 5, 10, 7 they are a part, but for this subarray they are not a part. For the subarray in which they are not a part, they cannot be answer, and for the subarray in which they are a part, 10 will dominate them, so they cannot be the answer. So basically 8 and 5 are useless, so I removed them. Then comes 7. Now 10 is greater than 7, so I will not remove it, I will keep as it is. Now I am at 4th index. Okay, so I have got the first subarray of size 4. So now at every step I will add the first element of my deque to my answer. Okay, so I will say my answer contains 10. Okay, now I will add 9, but 7 is less than 9, so first I will remove 7 and I will add 9. Also when I am at 9, so I am considering a subarray of size k which ends at this index, so it should contain these elements. Okay, so why am I noting that down? Because whenever the first element is not a part of the subarray, we need to remove that also. Okay, you will get it in a while. Now now the top maximum element of this deque is 10, right? These are not a part of deque. Okay, please be careful. Now 4, so 4 I will add as it is. 9 is greater than 4, so I will not remove it. Okay, so now I am considering the subarray 10, 7, 9, 4. Okay, the subarray of size 4 which ends at this index. Again the maximum element is the first element of the queue, that is 10. Now 15. Now before adding 15, please understand, when I am talking about 15, I am talking about this subarray which is of size 4 or k. Okay, now 10 is not a part of this subarray, so first of all I will remove it. Now 15, now 4 is less than 15, so I will remove it. 9 is also less than 15, so I will remove it. So there is only one element in my deque, that is 15. Okay, these all elements are removed, so the maximum element is 15. Now 12, so I will add 12 to my deque because 15 is greater than 12, so I will not remove it, and my answer for this subarray will also be 15 with subarray which ends at 12. So 9, 4, 15, 12, the maximum element is 15. Then I add 90. Now 12 is less than 90, so I remove it. 15 is less than 90, so I remove it, and I add 90 to my deque. The first element of the deque is my answer. There is only one element, so 90 is my answer. Now 13, so I add 13 to my deque, and 90 is the first element, so 90 is my answer, and I finish it. So my answer is 10, 10, 10, 15, 15, 90, 90, 10, 10, 10, 15, 15, 90, 90. In this way I will get my answer. Just to conclude, what we are trying to do is, we are trying to maintain a deque in which there will be at max k elements which are a part of the current subarray of size k. Then we will keep on moving index by index and consider the subarray which ends at index I of size k. Now before adding the ith element to the deque, we will remove all the elements from the front of the queue which are not a part of that subarray, right? If the ending index is I, starting index is I minus k plus 1. So all the elements in the queue which are of index I minus k or before that, we need to remove them. Okay, there will be only one element. If it would be, that would be I minus k. So we will remove it, and before adding a new element, we will see what are the elements at the back of the queue which are smaller than the current element. We will also remove them because they cannot be answer for any further subarrays of size k. We also saw why. Okay, so in this way we will get our answer. Now what would be the time complexity? The time complexity would be big O of n. Why? Because we are making one for loop, right? And we are adding and removing elements from the queue, deque. Now adding an element in a deque takes constant time, and removing an element from a deque takes constant time, and one element will be added once and removed at max once, right? So n elements will be added in the queue and n elements will be removed, so that will also take big O of n time, and we are running one loop that will also take big O of n time. So overall time complexity will be big O of n. What would be the auxiliary space? The auxiliary space will be, see, basically the queue will contain at max k elements at a time, so that will be big O of k for it, but this my answer array will contain n minus k plus 1 elements, because there are these many subarrays of size k. Okay, so you know, expected time complexity is said to be big O of k, but it's better to say big O of n because this will give a upper bound, right? Big O of k can be very small. Let's say k is 1. So n minus k plus 1 will be equal to n. So there will be n elements in my answer. I cannot say it constant time, right? So better would be big O of n. Now let's look at its actual implementation. So if we look at the actual implementation, so this is the array given in the input, this is size of the array, this is k size subarray which I need to consider. I have taken one vector answer in which I will add my answer. I have taken one deque in which I have taken a pair. Now why I have taken a pair? Because in pair I would add the element value as well as the index of that element, right? So whenever I am considering a subarray of size k, from the front of the queue I will check the index of that sub element in the deque and see whether it is a part of the current subarray or not. If it is not a part of the current subarray, I need to remove it, right? So that's why I have taken pair. Okay. Now if k is 1, that is we need to consider a subarray of size 1 only. So this is the base case which I have taken. Then simply I will add all the elements to my answer and return answer. Because if we need to consider only the subarray of size 1, that individual element will be the maximum element, right? So we will return it. Otherwise, what I will do, I will push the first element to my queue and also its index. Then I will start from index 1 to n minus 1. Now while q, now I need to add index I, right, to my deque because I am considering a subarray of size k which ends at index I. But before adding that element, I will check if the queue is not empty and q dot back dot first. What does this mean? Q dot back means from the back of the queue I am checking the last element, and dot first means, see, I am taking it pairwise. Okay, this will have the element value and this will have the element index. So I am taking value. This will be taken using dot first and this will be accessed using dot second. So if the last element value is less than the array of I value, less than equal to, then they are of no use. So I will pop from the back side. Okay, so I will keep repeating this process until the last element is less than equal to array of I. Now from the front side, while q is not empty and q dot front dot second means, q dot front means the first element of the queue and dot second means index of the first element which is in the queue. What is its index in the original array? If it is less than equal to I minus k, then pop out the front element. What does that mean? Let's say this is my array and I am considering this subarray of size k which ends at index I. So what will be the starting index? I minus k plus 1. So if there is any element in the queue whose index is before this, means it is less than equal to I minus k, right? Because the starting index is I minus k plus 1 and ending is I. So if there is any element in the queue whose index is less than equal to I minus k, then pop them out. Okay, and then finally add the current element in the queue, so the element and its index value, and if I is greater than equal to k minus 1, then only we will get a subarray of size k. So whenever I is greater than equal to k minus 1, answer dot pushback q dot front dot first. As I said, we will get a decreasing values in the queue and those values will be a part of the current subarray. So always take the first element which we will get by q dot front, and using dot first we will get the value. So directly add that to the answer. Okay, and we will finally return the answer variable. Now let's submit this code. Let's submit it. So we have solved this question successfully. I hope you understood the solution completely. Thank you.